Okay, this is going to be a guided practice problem that was at the end of notes on magnetic forces and corner right-hand rule. And this practice problem looks something like this. Part A says, what is the magnitude and direction of the magnetic force of this proton? We're given the magnetic field B and the velocity V. I'm going to use my equation that force is QV cross B. We're taking that cross product, becomes QVB sine theta. Let's take a look. This theta represents the angle between the velocity and the magnetic field. So if the velocity is to the left and the magnetic field is out of the page, this theta is actually just 90 degrees. And the sine of 90 degrees simplifies to just 1. So really I'm just looking at QVB in order to find force. First I'm going to need the Q, the charge of a proton. Luckily in our data booklet we are given the elementary charge. Remember, elementary charge is the charge of both a proton and an electron. The electron would simply be negative. So the charge that I need in this problem is 1.6 times 10 to the negative 19th. I'm given velocity, and I'm given magnetic field. Typing this into my calculator, I get an answer of 1.2 times 10 to the negative 15th. Units would be newtons. I'll then use my corner right-hand rule in order to get the direction. My thumb, representing velocity, is to the left. My pointer finger, B, is out of the page. That gives me a force that is upwards. Part B says that a second proton is moving in the same speed at an angle from the first one. Explain why the magnitude, spelled wrong, of the force does not change, but the direction would. Let's take a look at the magnitude first. We would start with F equals QV cross B or QVB sine theta. Remember that theta is the angle between the velocity and the magnetic field. So let's check. Velocity is up and to the left, magnetic field is out of the page. Well, that theta is still just 90 degrees. And so multiplying Q, V, and B together, the Q hasn't changed. It says the same speed, so the V hasn't changed, and the magnetic field would be the same as before, so the B hasn't changed. The magnitude hasn't changed at all. What has changed, though, is the direction. Let's check using the right-hand rule. My thumb is up and to the left. My pointer finger, magnetic field, is out of the page. That gives me a force that's kind of up and to the right. I know that I need to draw it in exactly at this angle to make a perpendicular angle, at least with velocity, and then with magnetic field out of the page. Finally, for part C, a moving electron enters a magnetic field. Which way will it turn? Well, I've kind of already done some of the work. I already did my corner right-hand rule in part A and found an upward force. But now that it's an electron, I simply take the opposite of that answer to find that this must have a downward force. So which way would this turn? Well, if my electron is moving along and feels a force tug it this way, and then that force changes, starting to make it go in a circle, this electron will go in a circular pathward that's kind of curving to the left and down.